Hello everyone and welcome to this video. Today we are going to learn how to find the area of a complex polygon. A complex polygon is something that is made up of other smaller, simpler polygons, which could be, in this case, we have a triangle, a square, and a rectangle. You could also throw trapezoids, circles, semicircles. You can mix any of those together to create a complex polygon. There are two different ways to find the area of shapes like this, and we're going to practice both of them. So let's get started. For this initial example, what we are going to do is first find the area of one large rectangle. I will outline that in white. So to find the area of that rectangle, you're going to take the base times the height, which is 3 times 4. So 3 times 4 will give you 12 feet squared. So in white, we have the area of the shape that is outlined in white. Now, to find the area of the multicolored shape, we will have to subtract the part that is missing. So we can do that in this reddish orange. We will need to find the area of that orange scribble and subtract it from 12 feet. So you may notice that is simply a triangle, but we don't have the measurements for that triangle just yet, but we could figure it out. Given the left side is 3 feet long and the right piece that is a rectangle is 1 feet long, we can subtract it to find the missing side here. So 3 minus 1 will give you 2 feet. And we use the same process for the top. Let me erase this so we can see easier. Okay, now we need to find the top. Again, you have 4 feet on the bottom, you have 2 feet on the top. Subtracting the two tells you that this space is 2 feet as well. So now the orangish red triangle is 2 feet times 2 feet divided by 2, the area of a triangle. So we have 2 times 2, all divided by 2, which will give you 2 feet squared. Awesome. Now, if we want to find the area of the multicolored shape, we simply subtract the white number, which is 12, from the reddish-orange number to give us our final answer, which we will do in blue, of 10 feet squared. So in this example, we found the area of a simpler shape and subtracted what we needed to find the actual area of the shape we cared about. Let's try a different way. You will notice we have the same shape here, but they're all colored orange, so we can color that in as well. Blue and yellow, awesome. And now we're going to try a different technique. We are going to find the area of the simpler shapes that make up the complex shape. So let's find the area of the yellow square. Well, the yellow square is 2 feet by something on this side. We don't know what that is right off the bat, but using the logic we know before, we know the whole left side is 3 feet, and we know that the right side here is 1 foot. So when you take 3 minus 1, that gives you 2 feet. So the square itself is 2 feet times 2 feet, which we will do inside of it, giving you 4 feet squared. Okay, now looking at the triangle, we know that from the previous problem that the base and the height of the triangle are 2 feet and 2 feet, and we can find the area of that. So 2 times 2 is 4, divided by 2 gives us 2. So we'll write 2 times 2 divided by 2, giving you 2 feet squared for the area of the triangle. And then probably the easiest part is finding the area of the rectangle. The orange rectangle's base is 4 feet. The height is 1 foot. So base times height tells us 4 times 1 gives us 4 feet squared. Now we add it all together. The yellow shape is 4. The orange shape is 4. and the blue shape is 2. Adding all those together gives us 10 feet squared, which you may notice is exactly what we found in the first example. In this case, I would argue the first method was simpler and easier. This may not be always true, it just depends on the problem you are given. Let's try one more example using both methods. Okay, we have another shape. This one is all orange and was not conveniently broken up for us. Let's try the first method of outlining the biggest shape and then subtracting what we don't need. Outlining in white the big outer shape, we have a rectangle. The rectangle is 6 centimeters high, and we need to figure out how wide it is. You'll notice we have 1 centimeter here, 3 centimeters here, and 3 centimeters here. So adding those all together, we know that the total length of this rectangle is 7 centimeters. Now we can apply our basic equations of base times height gives us the area. So we know that 6 times 7 will give us 42 centimeters squared. Now, just like in the previous problem, our next step is going to be subtracting what we don't need. We can highlight this in a yellow. It's this square. To find the area of the square, we use base times height. So we have 3 times 3, giving us 9 centimeters squared. Subtracting 9 and 42 will leave us with a total area of 33 centimeters squared. All right, let's try it using the other method. So when it comes to using the other method, it's up to you how you want to divide the shape. In some cases, it may make more sense to split it up like this, where you have a square, a rectangle, and a bigger rectangle, but it all depends on the measurements of the sides that they give you. In this case, we're actually going to change our approach from what's drawn on the screen to a tall rectangle and another tall rectangle like so. And you'll see why in a second. So let's focus on the leftmost rectangle. We have a height of 6 centimeters and a width of 1 centimeter. So 6 times 1 means the area of this is 6. Now let's look at the square in the middle. Maybe you didn't know it was a square right off the bat. So what you can do is you can look at the total height, which is 6, this height, which is 3, recognizing that whatever's left over will give you the height that you're interested in, tells you that this is 3. Now we have 3 centimeters by 3 centimeters, giving us 9 centimeters squared for the area of this shape. And lastly, we can rewrite 6 centimeters over here. Finding the area of the largest rectangle, you have 6 centimeters times 3 centimeters, giving you 18 centimeters squared. Now we have all three of those sorted out. 18 plus 9 plus 6 will give us 33 centimeters squared, which again is the same as before. All right, for our final example, they again ask us to find the area of the polygon. Go ahead and pause this video and try it on your own. Feel free to use both methods. For this one, I recommend starting with the additive method, where you find the area of all the orange shapes and add them together. Now that you've tried the problem, let's get started. First, we're going to find the area of the lower rectangles. We have 5 and 1, giving us 5 and 5 centimeters squared in each of those leg shapes. And then we need to find the top, which is going to be a trapezoid. From previous lessons, you should remember that the area of a trapezoid is equal to 1/2 the base of 1 plus the base of 2, which is going to be the top and the bottom, all times the height. Essentially, you're averaging the bases, multiplying it by the height. So we have 6 plus 3, giving us 9 over 2 times the height. Okay, now what is the height? The height is going to be from here to here. We know the whole shape is 11 centimeters tall, and the legs are 5 centimeters tall, telling us that this has to be 6. 6 plus 5 gives us the 11 for the total height. Okay, so height is 6 centimeters. Now we can simplify this. The 6 and the 2 cancel. Dividing by 2 gives us a 1 and a 3. 9 times 3 gives us 27 centimeters squared. And that is just the trapezoid. Now we have 27 plus 5 and 5. 27 plus 5 plus 5 gives us 37 centimeters squared for the entire shape. So this was the additive method. Now let's try using the subtractive method. This method is going to be arguably harder than the previous one because we're going to have to make a lot of assumptions to figure out what the area is of these missing shapes. First things first, let's find the area of the largest outside shape. So we have a rectangle, like so. We know that the base is 6 centimeters because of this value right here, and we know the height is 11. So our total area is 66 centimeters, and that is for the big outer white shape. Now we need to find the area of the blue shapes that we need to subtract out. Starting with the space in between the two legs, we know that this is 1 centimeter and 1 centimeter. That leaves us with 4 in between the two legs, and we know the height is 5 centimeters. So that inner shape is 20 centimeters squared. And sorry, that should be squared as well. All right, now we need to find the upper triangles in blue. The height of those we have already determined is 6 from the previous problem. Now we need to determine the width for each of those. This is where it gets a little tough. We know that this bit is 3 centimeters, and we know that the total width is 6 centimeters, which tells you that between both of those sides is going to be 3 centimeters. So chopping it in half, you have 1.5 and 1.5. To make sure we did this correctly, if you add all the numbers on top together, that will give you 6, which is the correct width. Now we have to find the area of those triangles. So we have base, which is 1.5, times your height, which is 6, all divided by 2. We can simplify that down to 3. So now we have 1.5 times 3, which may be a little confusing, but we can do that using multiplication. 5 times 3, 5, carry the 1, 4.5. And we have 2 of those. Make sure you remember that you have 1 on the left and 1 on the right. So we're going to have 4.5 and 4.5. Okay, let's clean this page up a little bit. Okay, so now we know that the big outer shape of the entire, call it building looking thing, is 66 centimeters squared. And then the space in between the legs was 20 centimeters squared, and each of the triangles was 4.5 centimeters squared. We have to take the 66 centimeters and subtract all of that, so that'll leave us with 66 minus essentially 29, and that'll give you 37 centimeters squared. So you may have noticed that this method seemed fairly harder than the other. So when solving these, take a quick look at the shape and try and guess if it'll be easier to add up all the smaller pieces or make a big piece and subtract one out like we did in the first two examples. Ultimately, both of the methods should give you the exact same answer, and it's a great way to check your work. Thank you so much for watching, and if you have any questions, feel free to leave them in the comments.